This lesson is another grade 9 topic about probability tree, but with quadratics. Now, you must be very good at tree diagrams, first of all, and also solving quadratics and algebraic fractions. We're going to combine all of these together, and it's not a surprise why it's a grade 9 topic, right? So, the learn objective, there's one learn objective, which is to solve probability tree questions that involve quadratics when the original amount is missing. So, start a question, pause the video, have a go at these three questions. When you're ready for the answer, you can press play. Here are the answers. I don't think I should be explaining too much in here. Everything should be quite self-explanatory. So if you got anything of these questions wrong, you should go back to the previous chapters before you come to this one, because you must have a very good understanding of these starting questions before attempting the question in this topic. You can follow these steps to help you to work out the probability tree question with the quadratics. Step 1. Use algebra to represent each of the amount of the original items. Now, it could be marbles, could be beads, could be balls, etc. Some sort of similar things they do the question like to use. Sometimes the question also give you the variable ready, so that's even better. Step 2. Draw a tree diagram using the algebra, a proper tree diagram, not the one like this one, okay? Using algebra. Next one, you form an equation based on the information given by the question. And step 4, solve the equation, or solve the question. Who doesn't know? Well, we are told to solve the question, right? Usually the quadratics. Example number 1, this one is with a replacement. There are 6 green counters and some yellow counters in a box. A counter is drawn randomly. The counter is put back into the box. Another counter is then drawn randomly again. So when we say it's with replacement, it means the counter is put back. So that's what replacement means. Means we're not losing any. The total number of counters does not change. This time we're not told about the total. So what we can do is, first of all, we let x to be the total number of counters. Now, then what we know is there are 6, and so the yellow will be x minus 6. Now, quite important to write this down because it helps you to visualize one less things, to think about one less things when it comes to doing the tree diagram. So, given the probability that 2 green counters are drawn is 9 over 100. Right. So what we can do is we can draw a tree diagram, step 2. So the first pick is green or yellow. Second pick could either be a green or yellow. Again, green or yellow. Right. So if there are x altogether, first of all, to begin with, there are 6 green counters. So the probability of getting a green counter is 6 out of x. And the yellow will be x minus 6 out of x. Good thing about replacement is the probability does not change, because if you pick one green counter, you put it back in, there are still 6 green counters in there. So 6 and then over x, and that's x minus 6 over x, 6 over x, and x minus 6 over x. So that's a good thing about replacement, is the probability doesn't change. Next, use the information given by the question. Given the probability that 2 green counters are drawn is 9 out of 10. So 2 green counters, a green and a green. If you know your tree diagram, you should know you're going to multiply the 2 probability along the root. So that will give you 6 out of x times 6 out of x. And what we do know is that inequality, so if I simplify that inequality equation, I mean 6 times 6 is 36, x times 6 is x squared. What we know is 36 over x squared will equal to 9 over 100. We're told the probability equals 9 over 100. Next, we can cross multiply. So 9 times, so cross multiply. 36 times 100 is 3,600 equals 9x squared. Divide by 9, 400 equals x squared. Square root the 400 is plus and minus 20, but we know counters cannot be negative, so it's 20. So therefore, the total number of counters is 20. Okay, and that's the answer. This time, another example, but without replacement. Without replacement means when you pick one marble out of or counter whatever out of the bag, the second time you pick it, it'll be one less. So you have to be very, very careful about the probability in the second pick. There are 4 red marbles and X blue marbles in the bag. So red, let me highlight that again with the replacement. So red is 4 marbles and blue is X marbles. So altogether, total, there are X plus 4 marbles. Right? A marble is drawn without replacing it, another marble is then drawn. The probability that both the marbles drawn are blue is 1 over 15. Work out a total number of blue marbles in the bag. So step 2, let's draw a tree diagram. So red, blue. Second pick, we could either draw red or blue again. Same thing in here, could be a red or a blue. Now the first time when we draw a red, it'll be 4 out of X plus 4 because it's 4 out of the total. Now, one could argue, why do we need to write down the probability of red in here or red and blue? Because the question only asks for 2 blue marbles. Yes, you're right. You can just work out the probability of blue marbles, but as a good practice, you should try to write down probability of all of them. It just as a good habit for your brain, just a bit of exercise for you to make sure you get these right. Now, next time when you draw a red marble, it's 1 less than the original. So there were 4. When you draw 1, there's 3 left. The total, it has also gone down by 1, so it'll be X plus 3. All right. So all of the second branch will be out of X plus 3. The first time you draw red, the second time, the number of blue will remain the same, which is X. Now your first pick is blue, the chance of getting the blue marble out of the first pick is X out of X plus 4. The second, when you pick a red, you pick a blue first time, the second time you get a red will be still 4, because the first time you didn't pick a red, so there were still 4 reds. But the second time when you pick a blue, it will be 1 less than X, it will be X minus 1. Now we know, oops, what's going on? So we know blue and a blue, so that will give you X over X plus 4 times X minus 1 over X plus 3. And we are told this will equal to 1 over 15. So my next task is to simplify the algebra and solve the equation. So let me rewrite this. So X times X minus 1 in numerator, denominator X plus 4 times X plus 3, and that equals 1 over 15. Now normally I'll ask you to keep the denominator same with the expanding, but here since we have to solve it, so there's no harm expanding the bracket since we can't cancel anything in the numerator anyway. So if I expand the numerator, X times X, X squared, X times 1 is minus X, denominator X squared plus 3X plus 4X plus 12 equals 1 over 15. I simplified the denominator a little bit, so X squared minus X over X squared plus 7X plus 12 equals 1 over 15. To solve any equation with algebra, you cross multiply. So that gives me 15 bracket X squared minus X equals 1 times, you don't have to put 1 times, X squared plus 7X plus 12, but just to show you how to cross multiply, expand the bracket, 15x squared minus 15x equal x squared plus 7x plus 12. To solve a quadratic, maybe think about what should you do next. You need to bring everything to one side and make it equal 0 on the other, because that's how you solve quadratic. So I'm going to bring everything from right hand side to left hand side. Reason being is the 15x squared is bigger than x squared, so you do want to keep the x squared positive in that sense. So x squared, remove it, it'll be 14x squared, plus 7x, remove be minus, it'll be negative 22x, plus 12 minus 12 equals 0. I see all coefficient is even, so I can divide everything by 2 to make my life easier. Now this question is non-calculator, so 7x squared minus 11x minus 6 equals 0. We're going to need a pair of numbers that multiply give negative 42, but add to give minus 11. I think the best pair of number will be minus 14 and 3. So it'll be negative 14 and positive 3. So you can split the middle term with negative 14x plus 3x minus 6 equals 0. If you remember, or if you've watched a lesson of me doing factorizing harder quadratics like these ones, I do always suggest put a negative first. If there's a negative number in there, do put negative first. So factorize 7x, it'll be x minus 2. This one factorize 3 out, x minus 2. So I can put them together, 7x plus 3 bracket times x minus 2 equals 0. So 7x plus 3 equals 0, or x minus 2 equals 0. X equal minus 3 over 7, or x equals 2. You can't have a fractional, let alone negative marbles, so we can reject that one. So x equals 2. So therefore, there were 2 blue marbles to begin with. Here comes practice question 1. Depends on your confidence. If you're not feeling like it, I can go through it for you, so you can listen as example. But I would suggest you try it yourself first. Pause the video now, have a go. When you're ready for the answer, you can press play. The final answer is 8. If you got it right, well done. Move on. But if you don't, I'll go for it. Okay, so first of all, one thing to note is without replacement. I've mentioned this. Without replacement means the second time or the third time when you pick it, will be the total will be going down by 1. There are n balls in the box, so total there are n. Okay, 3 of them are red, so red there are 3. The rest of them are green, so it'll be n minus 3 for green. One ball is drawn without replacement, and another ball is then drawn. Given the probability that a red ball and a green ball are drawn is 15 over 28, look at the value of n. So red and green, red and green, red and green. So first time when we draw, it'll be out of the total n, right? But the second time when we draw, it'll be 1 less, so n minus 1. So the second branch, we can do n minus 1. So I guess this is a little trick for you, a tip for you to do the denominator first. Now, when we first draw red, there were 3. Second time we draw red, will be 1 less, there'll be 2. First draw red, second time the green will remain the same as n minus 3. The first time we draw green, there'll be n minus 3 over n. But the second time we draw green, it'll be 1 less. Now, n minus 3 minus 1 is n minus 4. For green, for red, it will say the same, 3, because the first time we draw a green, there was still 3 red. Now, probably a red and a green ball. So red and a green, green or red. So we've got 2 branches. Each time we have to multiply them. So first will be 3 over n times n minus 3 over n minus 1. This one will be n minus 3 over n times 3 over n minus 1. Now what we need to do is we need to add them up. So if you have more than one root that give you the final answer, you have to add up the probabilities together. And we know that sum equals 15 over 28. So we'll do that. So let me write that. 3 over n times n minus 3 over n minus 1 plus n minus 3 over n times 3 over n minus 1, which equal 15 over 28. What we can do in here is we can just simplify each fraction. So 3 times n minus 3, expand bracket with 3n minus 9 over n times n minus 1. Plus in here you can see the same thing, 3n minus 9 over n times n minus 1 equal 15 over 28. So we can add them up together. So 3n, because they have the same common denominator together, so we can add them up. So 3n plus 3n, 6n, minus 9 minus 18 over n. If I expand the bracket, n squared minus n equals 15 over 28. Is this calculator? Non-calculator. Non-calculator. Ooh, okay. So, well, we are forced to deal with big numbers. Let's go through, why not? I do apologize to throw you in the deep end to begin with, but it is what it is. With this type of question, especially on calculator, you are expected to deal with some bigger numbers, but you can simplify it down later, you'll see. So cross multiply. So cross multiply. We're going to do 28 times that and 15 times the denominator. So we would have 28 times 6n minus 18 equals 15 times n squared minus n. Expand a bracket on both sides. Oh, actually, let me expand a bracket on both sides. 28 times 6n, 6 is 168n. 28 times 18 is 504. 15n squared minus 15n. Next, I need to bring everything on one side. So I'm going to bring everything on the right hand side because the n squared is on the right hand side. So 0 equals 15n squared. 168n to left hand side to right hand side becomes minus. So take away 183n because minus 15 take away 168 is negative 183, and then plus 504. Now usually big numbers like this you can simplify. Okay, so well 15, there are not many factors going to 15. 3, 5. 5 clearly doesn't go into 183 and 504, so we can try 3. Well, this one divisible by 3. This one looks like so. Actually it does. So if we divide everything by 3, so 0 divided by 3 is 0. 15n is 5n squared. This one is 61n. This one divided by 3, so it's 1. Remainder is 2, so 6 and 8. Right. So you need a product that multiply to...
I don't like where this is going.
5 times 168 is 840. You also need to find a sum that give minus 61. Now, if this proves to be too difficult, you can use a calculator. Just want to put one harder question there, just to show you you are prepared to do some of these stuff. It's a grade 9 topic. Ultimately, it's not just a method, but also numbers.
Emotional, damn it!
This one is minus 40 and minus 21. So we can split that into 5n squared minus 40n minus 21n plus 168. So factorize it in here. So 0 equals n times 5n. Oh, actually, we can factorize 5n out. 5n and minus 8 minus in here, we can factorize 21. So n minus 8. So 0 equals 5n minus 21 and n minus 8. So n equals 21 over 5, or n equals 8. We can have fractional marbles or beats or whatever. So n equals 8 is the final answer.
Nice.
This is practice question 2. If you weren't able to do the practice question 1 successfully, see if you can try to absorb the knowledge and try to do this one successfully. I've said the word successfully too many times. Do not give up. Okay, these questions are not easy, but try very best. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Final answer is 5. You should be able to work out x is 2 if you got 5 as final answer. If you didn't get 5, but you got x equals 2, you got 1 mark taken away. But final answer is 5. Okay, if you got it right, move on. If you don't, let's go through. So there are 3 red counters. So red is 3. Blue counters, there are x. So total is x plus 3. I tend to like to write the x in the front first. Okay, you can write 3 plus x, but sometimes it can be quite confusing. You know, sometimes it's just weird how a brain works. 2 counters are drawn randomly. When they say something like this, 2 they're drawn randomly at the same time means it's without replacement. Given the probability that both counters are drawn are red is 3 times, work out the total number of counters in the back. So we've got red and then blue, red, blue, red, blue. So start with, we've got x, to draw first red, with 3 out of x plus 3. To start with, we can start with denominator. It'll be 1 less, it'll be x plus 2, x plus 2, x plus 2, and x plus 2. And then it'll be 2, and this will be x. The draw blue will be x. Second time draw blue will be x 1 less, and there'll be 3 reds. Okay, so first of all, check your tree diagram, see if my answer is the same as yours. If they're not the same, why are they not the same? You might want to put a note next to yourself. Why are they not the same? Okay, what have you done wrong? I can't be wrong because I'm a math teacher, so you know I can't be wrong. Work out a total number of the number of red in the bag. So we've got 2 of them are red, so red and red. That's 3 over x plus 3 times 2 over x plus 2. So multiply them. That'll be 6 over x plus 3 times x plus 2. We're told this equals to 3 times, so we're going to solve the quadratic. So 6 over x plus 3 times x plus 2 equals 3 tenths. Expand the denominator. So x over x squared plus 5x plus 6 equals 3 tenths. Cross multiply. So 6 times 10 is 60. 3 times that will be 3x squared plus 15x plus 18. I'm removing 60 to the right hand side, so 0 equals 3x squared plus 15x minus 42. Each number is divisible by 3, so I will do that. I will divide every single number by 3 to make my life easier. So 0 equals x squared plus 5x minus 14. So all of a sudden it becomes very manageable. X plus 7, x minus 2. So x equals minus 7 or x equals 2. We know x cannot be negative in this case, so x has to be 2. That's x a number of blue balls, blue marbles. I lost count. So the total number will be 3 reds plus the 2 blues, which is 5. That's the answer. That's enough torture. So I've given you this time. You can use a calculator to try the question.
My time has come.
Pause the video, have a go at the question. When you're ready for the answer, you can press play. The final answer is 2. See if you got it right. If you did it again, well done, move on. But if you don't, let's go through. So total this time is x. 7 of them is white, so white is 7, and black is the rest of them. That means x minus 7. This time, same as the previous one, is not replacing the old marbles. So with that replacement, means the tree diagram will be 1 less in the second time. So let's draw a tree diagram. The white, black, white, black, white, black. I'm going to show you the, I'm not going to explain how to do tree diagram, so you should be able to do it by now. So here's the tree diagram. Now, as you find your line should be black and black, so it should be x minus 7 over x times x minus 8 over x minus 1. X minus 8 because minus 7 minus 1 is minus 8. So they want us to do the probability of 2 black marbles. So yes, so x minus 7 over x times x minus 8 over x minus 1. You can expand it here, you can expand it next step, doesn't really matter. What we know is the product that after multiply should equal to 5 over 33. So we'll do that. So x minus 7 times x minus 8 over x times x minus 1 equals 5 over 33. Expand the numerator, x squared minus 15x plus 56 over expand denominator, x squared minus x equals 5 over 33. Cross multiply. So 33 bracket x squared minus 15x plus 56 equals 5 times x squared minus x. Do expand the bracket and simplify the quadratics. I'm going to show you all the steps in between. So if you do successfully, you can see the steps should be as follows. Expand the bracket, put everything on one side. Good thing is this is a calculate paper, calculate question. That means you should be using quadratic formula to solve quadratic equation. You can see the hence justifying the big numbers in the question. So use the quadratic formula nicely, you will get 12 or 5.5. You can't have a decimal marbles. Again, lost counters, whatever. So x has to be 12. And but we're not asked about what's the value of x, aren't we? We're asked about how many more white marbles are there than black marbles. Because we now know x is 12. That means we know there are 12 minus 7, there's 5 blue marbles. So the difference is 7 minus 5, which is 2 marbles. And that's the final answer. Can you see that little brightness of hope at the end of this darkness of probability tree tunnel shenanigan nightmare? We're getting there. The last question about Rachel as a biscuit tin. If there's one thing you don't know is there's everything in a biscuit tin apart from biscuits. Anyway, pause the video, have a go at the question. When you're ready for the answer, you can press play. Here is the final answer. Okay, the final answer is 15. Okay, the final answer is 15. If you got it right, well done, move on. But if you don't, here's the answer, step-by-step answer. The orange, there are 7. Chocolate biscuits, x total, x plus 7. As I said, I tend to like to put an x in the front first. Okay, it will make your life a bit easier when it comes to starting out when you do the -1 thing. And then here's the tree diagram. Check your answer, see if you got it right. Check the tree diagram. If you do correctly, you should get 2 fractions, which are both 7x over x plus 7 times x plus 6. Add them up, equals a over 15. Cross multiply. Use quadratic formula. You solve x equals 8. And don't forget to read the question. They want you to find a total number of biscuits in a tin, which we know is a lie. There wouldn't be 15, but there are 15 apparently. It is what it is.